Hello and welcome. This is another chapter from the Mark Ciampa book, Wireless Security. And this one is securing wireless transmissions. And securing transmissions or data transfer is not just a wireless issue. Bigger issue with wireless because, as we have seen in the past, wireless is available to anybody that can receive the signal. So when we're sending data, we really would like to make it as secure as possible, and there are going to be a couple of at least different ways to do that. Keep in mind, when you're securing data, there's two separate processes. One's encrypting it on the hard drive, the storage media. The other is when it actually goes onto the network, and the two are not the same. If we use something like the Windows encryption, when we encrypt a file and we transfer it, it's actually decrypted before it's put on the wire. So we need a separate encryption protocol when we go on to the network. And with that, I'd like to take a look at the presentation here. The objectives for this one explain how documents to be transmitted wirelessly can be encrypted. A number of different protocols that we can use to do that. Keep in mind that this is, once it gets off of the machine itself, how can we encrypt the connection. Listen, describe the secure management interfaces for encryption. Tell the features of the virtual private network and how they're used to secure wireless transmissions. VPNs are a great way to do that, because what a VPN basically is an encrypted connection across the internet or across a network of any kind, depending on where the VPN goes from to. We are back to the private key, public key cryptography. The private key, the shared key. The problem with private keys really is key management. How do we keep the private key private when we do these things? Public key cryptography issue with that is speed and resources it takes to do that. What we typically wind up with is a situation where we create a private key and encrypt it with a public key, send the key along with the document, decrypt the key, and then use the private key or the symmetric key in order to actually decrypt the document, whatever it was that we sent. Private key, basis of the pre-shared key. This would be for our home use, not enterprise use of WPA, WPA2, and WEP2 for that matter. Uses a single key to both encrypt and decrypt the document. Advantage here is it's going to be much more efficient, much faster. The problem is key management, sharing the key. Who gets it? Who can actually keep it a secret? Provides a weak degree of protection because of problems associated again with managing the keys, and that is a really big issue with the private key, with the symmetric key, with the single key, same key in all of the different locations. This is just encryption options when we're looking at picking an encryption protocol, and they're all RC4. Nice visual there. Public key asymmetric. It does solve the problem with the key distribution. The keys, in order to be trusted, have to be from a trusted third party, a trusted certificate authority, and you can see those in Internet Explorer if you want to look and see who are the trusted certificate authorities. If you issue your own certificate, you can add your certificate authority to the list. So what these things are, two mathematically related keys that are used instead of just the one. We have a private key, which really needs to be kept private. If it's not kept private, then it compromises the whole system. And then a public key, and it's public because everybody can have it. What we do in this situation is we encrypt with the public key and decrypt with the private key, and I think in other presentations we've talked about doing that. Public key can be freely distributed. You can put it on a website, put it on your Facebook page, whatever you want to do with it. PGP, pretty good privacy, and GNU Privacy Guard, GPG, are cryptographic systems, and they're talking about them as PKI. They're really kind of sort of are and kind of sort of aren't. What you have to do with those is share your public key, and you can go to PGP, I think it's pgp.mit.edu, and post your key there so that others can get it. Again, it's a public key, so if somebody's going to encrypt something that comes to you, they need to have your public key. PGP, wonderful piece of software. You can use it for encryption. Does a really great job. It is a commercial on www.pgp.com is where we would get to it. GPG is similar to PGP, but it is the open source version of these things. Each of them generates a random private symmetric key and uses it to encrypt the message. The private key is then encrypted to use the receiver's public key. This is what I was talking about before. What we do in these things is we create a private key to encrypt the document. We then encrypt the private key with the public key with the PKI structure so that we minimize the resources that are required to actually decrypt the document. When it gets to the other end, then we would use our private key to decrypt the symmetric key, and then we would use the symmetric key to decrypt the document itself. It's kind of a good system. Uses both private and the single key symmetric and asymmetric encryption in this case. The Linux cryptographic file system can encrypt files or selected directories and files on the Linux system. It's not used for sending files. It's used for encrypting files on the storage media, just like the Microsoft encryption is. The encrypted file system, EFS, is used to encrypt documents on the storage media, on the hard drive, on the flash drive, on the server, wherever we're storing the information. Secure FTP, Secure File Transfer, is a file transfer protocol, connects to an FTP server, and when we do that, we would get a certificate from the server, and then we would use that certificate. We would use all the whole process in order to generate the encryption, but the certificate is going to actually identify the server as the one that we're actually trying to talk to. The secure file system can be used to connect to these things through the web browser or using an FTP client or from the command line. Any of these systems. One that is maybe kind of handy to have is when there are a number of you using Windows, a number of Windows clients. Problem with FTP, if you'll go do an FTP connection and run Wireshark, FTP is unencrypted. Not only is the connection unencrypted, you can get the passwords, you can even read the data out of an FTP file if you're using that. It's vulnerable to man-in-the-middle attacks. You never have to do a man-in-the-middle. Well, you would to actually get through where you're using a switched environment. But what you've got to be able to do is to be able to see the port that the data is coming from, obviously. The binary files are converted to clear text before they're transmitted. If you really want to see one, go do that. Go open something from a public FTP server, ftp.microsoft.com, for instance. Download it, run Wireshark, and see what the results are. You're going to see the username, password, and then the Microsoft one is an anonymous connection, so you wouldn't have any problem getting to it. It's too hard to see. What this has is an FTP client. Let me pause this and see if I can get up my FTP client, my secure FTP client. This is a client called WinSCP login. The protocol is FTP. When I pick port 990 here, then I get the TLS implicit encryption. I can log into the system, and when I log in, it's going to go through the process. Let me see if I can resize this thing so that you can actually see it. When I get into it, I have my files on both my computer and my other side. This is a website that I kind of maintain. So if I look at these things in the options, preferences, we have a number of different things here, and then the security, how we're going to do that. This thing actually does have a, if I can find it, server protocol information. Has a certificate. We can look at the full certificate here. What this one says is that, yeah, I got one. This is on a website. I got one from the site. It says it may not actually be what I'm trying to connect to. Something may be trying to fool me. So I have connected to this thing, running TLS, SSL, implicit encryption. Yeah, cryptology, encryption here. And we use the FTP protocol, so we've encrypted that connection to get to these things. This is what would just be a an FTP connection. I'll go to a command prompt here, and let's see if we can get to that Microsoft ftp.microsoft.com, and it says that the user, and this is going to be anonymous, and the email, and you can use any email address as long as it's the right format. I like to use me@u.com, and I'm logged in. If I give the ls command, I get a listing here. If you go there, try going to one of these folders and see if you can download something. See if you can find a text document to download, and you can actually read those things in it. So we can get to FTP and secure FTP through the command line. Secure FTP reduces the risk attack based on one of two protocols: secure socket layers or secure shell. SSL was developed by Netscape for securely transmitting documents, and TLS guarantees privacy and data integrity between applications communicating over the network. One of the things when you see TLS, it's an extension of SSL, think certificate. So you're going to have some sort of a certificate exchange in order to do that. And I did have a certificate exchange in mind. Two layers, the TLS handshake protocol and the record protocol, provides protection from man-in-the-middle attacks, and one of the best protections from man-in-the-middle attacks is encryption. If you want to try some out, go get Canable, execute a man-in-the-middle attack on yourself using a non-secure as well as a secure connection. If you take the certificate from the bad guys, then shame on you. It will offer a certificate, and if you do that, then the man-in-the-middle attack will have been successful and be able to compromise whatever is going through, because what the man-in-the-middle does, you send it to the man-in-the-middle, then sends it to the correct location. If you take their encryption, then they can decrypt the stuff and use the regular encryption to get to the other end. But it should provide protection from the man-in-the-middle attacks and protection from packet sniffing during these things. Public key cryptography, this is a configuration of an email connection in a Windows system. You may or may not, depending upon your ISP, use an encrypted connection, an SSL connection to your email server. You obviously want to do that because email is inherently kind of dangerous because it is unencrypted. It's little text files, and again, they can be intercepted and read unless they are encrypted. Secure file transfer, more here. The Unix-based command interface uses this thing, 3 utilities: slogin, secure login, SSH, secure shell, and SCP, secure copy, when we do these things. The client and server are authenticated to each other using digital certificates, and the passwords are protected by being encrypted. And it can even be used as a tool for secure network backups. Keep in mind, however, when you do security, computers are much faster than they used to be, but it still takes resources to encrypt and decrypt data. That's one of the knocks of the public key infrastructure, is that it takes an awful lot more resource to use the public key infrastructure than it does the symmetric keys. And what we're talking about is maybe 100 times more resources in some cases. This is a summary of the rlogin, RCP, remote copy and remote shell, and the commands that we're going to use for these things for slogin, scopy, and SSH secure shell when we use the SSH protocol. Public key, secure copy, SCP, transfers files securely, encrypts during the transfer, data during the transfer. And again, that's the whole objective of whatever we're using here, is to do a secure transfer by encrypting the files. And there are a number of protocols that we can do, a number of processes that we can do to do that. If you're using FTP, we talked about secure FTP. Secure copy, command line, it is a Linux-based system, but the Windows, the FTP client that I have was a Windows secure copy, which has been ported to Windows. GUI-based clients are not pure SCP clients. The command line interface would be. Important to use encryption in wireless devices, because anybody that can see our network, can see our data, can receive our data, can record our data. The technologies: SSH, port forwarding, HTTPS, and SNMP v3. SNMP has 3 versions, 1, 2, and 3. 3 is a secure version. 1 and 2 use these really clever concealments called public and private, so that we have the public and the private SNMP communities. SNMP v3 actually uses usernames and passwords. SSH port forwarding, called tunneling. What we do in a tunnel is encrypt everything, including the IP address, and then put a new IP header on the system so that it can get to the other end. What we're doing in tunneling is creating an encrypted, totally encrypted packet and sending it from point to point across the internet. Does it mean that it can never be intercepted and never be decrypted? Absolutely not. Secure access to other services that don't normally encrypt data during transmission, because anything that goes into the tunnel will be encrypted. TCP connection to an external application is not secure, can be redirected to the SSH program, and that's why it's called redirection. Party forwards a connection to the desired destination host. HTTPS, plain HTTP, sent over SSL, and TLS, transport layer security, secure socket layer, designed to transmit individual messages securely. That's what we're typically going to use for a secure website. HTTPS, a little lock. Server sends us our its public key. We generate a symmetric key, encrypt it with a public key, send it back to the server. Both of us now have the session key that we, the client, have created, and use that symmetric key in order to encrypt and decrypt the transmissions. Advantage there is somebody gets the key, they have a session key, not something that's used for months, years, days, months, days, years, days, months, years, hours, whatever else. Most wireless devices can be managed through a web interface, including probably our home router. It can do HTTP or HTTPS. Typically pick one or the other, and this is one that you probably can't really see, but it allows us to pick HTTPS to manage this Linksys Soho router. SNMP v3, kind of talked about that already. Simple network management protocol, used to manage network devices, also to monitor network devices. Manage devices. Has an agent or a service that listens for commands and then executes them. Historically, using SNMP v1 and v2, using these guys, we have a community string. And these community strings are cleverly named public and private. SNMP3 replace the community string with usernames and passwords along with an encryption key, so it becomes a secure protocol that we didn't have before. VPNs, drawbacks of public-private cryptography: the user must consciously perform a separate action or use special software. So what they're saying here is that in order to actually get something encrypted from point A to point B, we've got to do something. What a tunnel is going to do for us, or a VPN is going to do for us, is automatically encrypt that data. These actions protect documents that are transmitted. Again, this is what we're talking about here. The protocols are once they leave the machine on the NIC, visualize, get on the network, that's where these encryptions take place. Some other communications across the local area network are not secure once we do these things, but what we're going to do is anything that goes in the VPN will be encrypted or will be private. And essential tools to talk about for road warriors, people that travel a lot now, instead of having to dial back and maintain a bank of modems at the corporate headquarters, we can allow the travelers to create a VPN connection from their hotel room and get on to the private network so that they can get data, send data, whatever else. And one of the things they talk about typically is salespeople who get orders and they want to update the database on a regular basis, so we can do that. A virtual private network uses the unsecured internet, and it encrypts the transmissions so that we can go from point A to point B and have a secure connection. VPN types, remote access VPN for virtual dial-up. It is in Windows is a dial-up protocol, which means that if you're going to use it, you're going to have to go into the properties of the users that are allowed to use this VPN and give them access to dial-up. The default is no. What you want to do is allow them to be yes. So we have site-to-site VPNs. We can have remote access, which goes from the server to, or from the client, from me to the server or to the VPN. And then a site-to-site VPN, which is going to be called a tunnel, that goes from point A to point B. VPN protocols, point-to-point tunneling protocol, based upon it's the most widely deployed point-to-point tunneling protocol. It's easy to configure and allows the IP traffic to be created and then encapsulated in an IP header, be sent across a wireless or public network, either one. When we do these things, if you want to configure a VPN on a Windows server, it's not very complicated. When you do the configuration of the routing remote access, just simply pick VPN and you will have created a VPN endpoint. It's based on the point-to-point protocol. Link control protocol is an extension that's used in this thing. It establishes, configures, and automatically tests the connection. And LCP is something that is going to be a part of many wide area network serial connections if you look in the Cisco world when we do these things. So VPN tunneling protocols, picture here the VPN connection, the point-to-point tunneling protocol connection, cable modem, the remote network. Okay, a little bit different picture. When we talk about these things, a VPN tunnel, what we do is, and I'm going to have some pictures here in a minute of a little bit better what happens to the packet. But we encrypt the entire packet, including the private IP address, put a public IP on it or a recognizable IP on it, and send it across the network, or the internet, in this case the cloud. So we're going across these things. We show these nice cool little tunnels to the endpoint here where it's stripped off and it goes on we're going to go through to the VPN server where it's going to be stripped off and then distributed on the network. We show these nice tunnels, but remember what we're really doing is going over multiple routers. And the reason we have to put the new header on is the routers can't read the encrypted information. So tunnel goes from the remote client. This could be site to site. What we could have in here is a VPN server that goes through here, and then the remote client goes through the VPN server. Everything that goes to this private network back here is going to go on to through the tunnel, when we have rules that send traffic to the tunnel. The other method of doing these things, if I can get this one in here, is the transport mode. What we have here is a situation that we encrypt the data, the local tunnel, we leave the IP address unchanged and send it through the tunnel across the internet to the other end, where it then will decrypt the data and send it to wherever it's supposed to go. And again, depending on the rules that we set up, we're going to send the data down the VPN tunnel. So in these things we have a client, the DSL, the network access server going through the internet, the point-to-point tunneling protocol server, and the remote network. So what we're doing is point-to-point connection, point-to-point tunnel protocol connection. We're going to encrypt the data. Simulates a dial-up session, and if you're configuring Microsoft point-to-point, then you're going to use a dial-up connection in order to actually do that. Layer 2 represents, this is a merger between point-to-point tunneling protocol and Cisco's Layer 2 forwarding, and it allows the IP traffic to be encrypted and then transmitted over to medium, and supports point-to-point delivery. So a little bit higher level of encryption. Point-to-point tunneling protocol is the easiest to configure. IPsec, IP security. IPsec is actually a framework that we put the different components into, much like the OSI model. It's layered. We can put whatever encryption protocol, whatever authentication protocol, whatever hashing protocol into it that we desire, and use it that way. To set up protocols, develop to support the secure exchange of packets. It's not a protocol itself, it actually is a framework. And these are tunneling protocols, what we're going to use in the different layers of the OSI model. When we look at these things, the application layer, PGP, we talked about GPG would also be here. In the session layer, we have Kerberos, HTTP, UDP, SSL, the transport layer, TCP, and then at the network layer, IP and IPsec are going to be used there. Areas of protection. Authentication header doesn't encrypt anything. It simply ensures that we're connected to who we think we're connected to. It's used for authentication, just like in its name. Confidentiality encryption is done through the encapsulating security payload, or ESP. Key management through the Internet Security Association ISACAMP key management protocol, or Oakley protocol. So the different protocols that are involved in this thing: authentication header to be sure we're connected to the right place, ESP to encrypt the data, and ISACAMP to manage the keys. Encryption modes. Transport mode encrypts only the data portion of the transmission. So we talked about this, tried to show it really poorly, I think. Tunnel mode encrypts both the header and the data. And if we use tunnel mode, then we have to put a header on it, an unencrypted header, an IP address, so that it can get across the network. Transport mechanisms, authenticating header, each of these in ESP, each of these in transport and tunnel mode. Tunnel mode encrypts everything, transport mode only encrypts the data. And you don't necessarily encrypt things all the time. Sometimes you just may want to be sure that you are connected to the correct location. This one shows, let me get my little arrow back, the new header is going to be the public IP. We have the original header, the TCP, and the original payload. So we take the original packet, the entire packet, and encrypt it. Put the new header on it, the new header, basically the new IP header, so that it can go across the internet. Because again, if we use that encrypted packet with the original header, the encrypted header, the routers aren't going to be able to read it. This one more looks at the header information here. In authenticating header transport, we have the original IP header, the authentication header, the TCP, and the payload here. In tunnel mode, we have the new header, the authentication header, which is going to prove who we are, the original IP header, TCP, and the payload. So in this one, we're going to encrypt the entire packet. In this one, we're only going to encrypt, or actually in this one, we're just going to use it for authentication. We're not going to encrypt anything. Each of these serves a purpose. I think that I had these encrypted. These are actually just going to be the authentication header where it actually goes. Tunneling protocols, in these we're actually going to encrypt something. So we encrypt the original and the TCP, and we have the ESP header and the ESP authentication data, and then the original IP header. And in this one, this is going to be transport mode, because transport mode only encrypts the data. Down here in tunnel mode, we encrypt everything from the original header back to the trailer data. The ESP authentication data is going to be here. ESP security, the new header, which is going to basically be the new IP address, so that it can get across the internet. This table gives you the security level of each of these things. Point-to-point tunneling protocol, easy to configure, has moderate security. Layer 2 has high security, a little bit more difficult to configure, and IPsec has high security. Hardware and software can be achieved through communicating with endpoints. Can be a tunnel between VPN devices. Can also be software. You can create a VPN between two Windows XP machines, Windows 2, Windows 7 machines, two Windows Server machines, however you want to configure it. VPN concentrators are kind of handy, because if you have a lot of VPNs, I used to work at a place where we had like 10 or 12, I don't remember exactly, VPNs. The VPN concentrator made it a lot easier to manage the connections rather than trying to go into the individual routers and configure them and keep them configured. To provide pass-through VPN endpoints, provide pass-through VPN capability. That's one of the problems, one of the things you may run into with routers is when we look at some of these things, when we put a new IP header on, it kind of appears that we're trying to hack the system. NET frequently breaks IPsec. What you have to configure is a pass-through through the router itself, so that you can actually effect the connection. Built-in VPN endpoint. If you use Windows, you can create a VPN endpoint through the network configuration. Let me see if I can get that up here and go through it quickly. I don't have a VPN that I can connect to, but I can go through the process with you. Okay, so I've opened the Network and Sharing Center and resized it so it would fit into this thing. What we would do here is to set up a network connection, and then in the network connection we're going to set up a wireless broadband or dial-up connection. What we want to do here is, not that one, we want to connect to a workplace, set up a dial-up or a VPN connection, and again, VPN connection is one that requires a dial-up authority, and in this one I'm going to say no, create a new connection. When we go through it, use the use the existing network. We can go back to here. Let's go back and do that again. We're going to set up a network connection. Bring this one over here. Connect to the workplace. No, create. Next, we want to use my internet connection, a VPN. We put in either the fully qualified domain name or the IP address of the system. And this one is not going to work. And the destination name is going to be what we want to name this thing. How we're going to use, what we're going to use for authentication, and whether we want it to be just for me or for anybody, other people to use the connection, anybody on the machine. So we can go next here, put in the username and password, and this is going to be the username and password on the network that's allowed to use the dial-in connection. Once you do that, and the domain is optional. You may need to do the domain. When we get this thing, it's not going to be able to connect, obviously. Connection is ready for use, so I should be able to go into my networking, change adapter settings, and this is the one that I just did. And if I wanted to change the properties, I could go in here and do that. What am I going to do for security? If I wanted to specify one, I could, or I could leave it as automatic. Require encryption or no encryption necessary. Networking, how we want to configure the networking. So that's basically the Microsoft built-in VPN client in order to do those things. Types of VPN operating system, freeware, VPN vendors. You can go look for open VPNs that are available on the internet. If you want to try them out, use some of those things. That's what we just did. Software. The VPN is actually software running on the wireless device itself, so that we can connect a VPN to it. Once we VPN to the wireless device, then we've created a secure connection to it. If we have two devices on it that we want to be secure, we can create a VPN from point to point across the wireless. So you can use wireless, you can make wireless fairly secure by using these things. It takes, again, a little more effort to do the configurations, more effort to do the management, and more resources to actually run the software. So the advantage of these things, flexibility in how the traffic's managed, more desirable again here for the road warriors, make it as simple as possible for your people that aren't on the network, that don't have access 24/7 to the help desk itself. When performance requirements are modest here. Disadvantages, do not have as good a performance, and we've talked about that as a hardware-based VPN. Hardware-based VPN obviously is going to be the preference. Typically anything you can do in hardware is going to be more efficient than anything that we're going to do in software. Processing is built into the system itself, and it's optimized to do that particular function. Hardware, more secure, better performance, and I think we've kind of have covered at least some of that. Only network devices serving as pass-through VPNs manage the VPN functions, or leave the wireless performing any of the VPN activities when we do these things. Can protect all the wireless devices behind it. Disadvantages are the enterprise VPNs can be expensive, and it's necessary to match the vendor VPN endpoints. You can usually get them to, if you can get down to the standards, to get them to talk to each other, but it's easier if you use the same vendor for each of the endpoints. Hardware-based, separate VPN appliance integrated into existing equipment. Enterprise level access points may have a VPN built into the functionality. Typically the home router won't, although some of the newer ones are getting more and more capability. So you probably want to look at the properties, what's available, the functionality of the device that you're buying. usually support a pass-through VPN, which means that it will not break our VPN as it goes through the network. Hardware-based VPNs, in this case we have the VPN device, and this is going to be our tunnel type arrangement when we go from point to point here. So we have the VPN device at each end, and then we're going to cross the internet. The decryption, encryption, and decryption are going to happen on the VPN device, and it's going to be encrypted as we go across the network. The red's going to be the encrypted data. Once we get to these points, then we have unencrypted data unless we do some other sort of encryption on the back side. So everything on the back side until it gets to the VPN is going to be unencrypted, which may or may not be a problem dependent upon your network. Just that you need to know that just because we have these VPN devices doesn't necessarily mean that everything's going to be encrypted. We're going to have some unencrypted data when we use a tunnel. If we used a transport layer, then the data would be encrypted totally across all components of the network. Home hardware based, and again this is another one, you may or may not have VPN capabilities with these things. Encryption at layer 2 and 3 of the OSI model supports IPsec, point-to-point tunneling protocol, and layer 2 tunneling protocol. I think probably the names kind of help identify what goes on with these things. IPsec, I think IP is the key there. Point-to-point tunneling protocol, or a layer 2 tunneling protocol. Point-to-point protocol is a layer 2 protocol, and we have this one is named layer 2 tunneling protocol. So this is where it's going to take place. Traditional routing is based on a connection level information. Layer 2 and 3 often can't keep pace with the data volumes. Layer 4 through 7 devices provide intelligent traffic management when we do these things based upon the content of the session. Application layer routers, application layer devices, the higher up in the OSI model, the more control we're going to have for any of these things. The advantages and disadvantages: advantages, cost savings, scalability. We can add more connections. We can allow more people to connect. Full protection depending on how we set it up, whether we encrypt the data, and if we encrypt the data and the header, again, we have to put a new header on it, but we've then protected not only the data but the structure, or at least the IP addressing scheme of our internal network. Full protection, speed, transparency, authentication, and industry standards are all used here. Speed is going to be relatively fast. Transparency will set it up so that the individual users aren't burdened with trying to set up the connection every time. And then the cost savings and the speed, we don't have to have these modem banks anymore. Disadvantages: it does have to be managed. Availability and performance: anytime that we encrypt and decrypt, we're going to affect the performance somewhat. Interoperability: are the different vendors' devices going to function with each other? Additional protocols are required. And again, performance impact and expense. If we're using hardware devices, we're going to have some expense with these things. Wireless encryption, an open hotspot, and for secure management interfaces, if you're at a wireless hotspot, it is going to be open. It is not going to be secure unless you use one of these other encryption methods that we've talked about. Everything that you put on the wireless is going to be visible to everybody that can receive that signal. The tools: SSH, HTTPS, SNMP v3, the things that we've talked about. VPNs, wonderful way to protect the data. Okay, with that, if you've managed to make it all the way through, I really would like to thank you for watching. I hope this has been useful, and thank you for watching.